Here's our last example for a bow tie problem. This time it's right, left instead of top, down. Again, all you want to do is draw one triangle and know that you're going to invert the other one. And so if I look at this one, I think I'm going to leave this big one just the way it is. So I'm going to outline it. You have to break it at the point. You always break it at the point, which means that this other triangle is going to look similar to it. The top value has to rotate around and become a bottom value. So now it's a bottom value if I put the 5 right there. And this right-hand side has to come over as a left-hand side. So I can call this G plus 4. And then just connect the sides there. And so really, I'm going to kind of scratch that out there. All I'm looking at is this triangle to that triangle. I want to set up a proportion. On this proportion, the numbers don't reduce. So it doesn't really matter how you set it up. I think I will go 2g plus 1 is to 12. 2g plus 1 is to 12. As, now I have to be consistent. Since I went vertical is to base, I have to go vertical is to base. G plus 4 is to 5. Now as I try to solve a proportion like that, I'll multiply by the common denominator, which is 5 and 12. I distribute to this first fraction, the 12s drop out, and I'm left with 5, bring this down, 2g plus 1. To the second fraction, the 5s cancel out, and so I'm left with the 12 and a g plus 4. And then that's the equation we want to solve. Let's see what happens. 5 times 2 is 10g plus 5, as I distribute that to both parts. This will be 12g plus 48. 12 times 4 is 48. Darn my luck. As you look at this problem, do you notice something crazy that's going to happen? If I move these as I'm supposed to, the 10g goes over here, and the 48, we're going to take that way. I'm going to get 5 minus 48 equal 12g minus 10g. 5 take away 48 is negative 43, equaling 2g. Big problem, can't have that negative. But again, I'm just showing the idea, the concept of how to set these proportions up. I wasn't really that concerned about the answers. And so when I get this, I'm going to have g equaling negative 21 and 1/2. And then I have to plug that back in to find each of these lengths. So I'm going to come over here, try to clean this up a little bit. G equals negative 21 and 1/2. And then my two sides, I have a g plus 4. So if I add 4 to that, that would be negative 17 and 1/2. Again, that doesn't make any sense. Negative answers are not possible when you're doing true proportions. And then 2g plus 1, proportions on shapes, mind you, would be 2g plus 1. That would be negative 43 plus 1, which is negative 42. So there's the arithmetic answers that I get, but in the context of the problem, as I've said so many times, you should never get negatives. This is a poor example of me throwing problems together that just didn't work because I didn't take the time to come up with values ahead of time. But we're more interested in just the process of solving these. That should be enough that you should get through your homework, and we'll talk more about this later.